Hello, this is Valentine from Simplistic, and in this problem we're going to calculate the change in entropy that occurs in the system when you have 10 grams of acetone vaporizing from a liquid to a gas at its normal boiling point, which is 56.1 degrees Celsius, and delta heat of vaporization is given to you as 29.1 kilojoules per mole. So the first thing to realize is if you have any compound, so in this particular case it's acetone, changing its state, so it's going from liquid to a gas, right? So acetone liquid to acetone gas. So the temperature at which this takes place is the boiling point in this case. So T is equal to 56.1 degrees Celsius. And the heat that will be taken up at this constant temperature to change from the liquid to the gas is given by the heat of vaporization. And what this means is you have 29.1 kilojoules heat is needed for every 1 mole of acetone. Now, what's important to remember is that they're asking you for 10 grams of acetone, not 1 mole. So we have to factor that into our calculation. So let's start with the formula for figuring out delta S, which is the entropy change, okay? So that's the change in entropy. So delta S is equal to change in the heat of vaporization, so delta H over T. That's the formula. Delta H is given to us as 29.1 kilojoules per mole, and the temperature is given to us as 56.1 degrees Celsius. Okay, so what we have to do is we have to make sure we convert all of this, okay? So before we should not simplify at this point in time. Why? Because the units of delta S is actually joules per Kelvin, okay, which means we have to convert the kilojoules into joules. So to do that, we take 29.1 kilojoules and we multiply it by 10 to the power 3 joules over kilojoules. Okay, so that should affect the conversion. And then what we have to do after that is we have to change the temperature. Okay, so we have to change the temperature to Kelvin. So 56.1, we need to add 273 to that. So then that becomes Kelvin, okay? And then whatever you get from this, okay, that is going to be equal to, that's going to actually, we have to convert that to grams, okay? Sorry, we have to convert whatever we get from this would be for every mole, so we have to convert that to 10 grams. So let's go ahead and simplify this first. So it turns out if you plug that into your calculator, you get 88.4 joules per mole, degree Kelvin, okay? Per mole Kelvin, okay? Now, the next step is, see, we get joules per Kelvin, but it's for every mole, right? So we have to factor, we basically have to factor the molar mass of acetone in. So the molar mass of acetone, if you calculate it, is, so the formula of acetone is C3860. So the molar mass is going to be 58.08 grams per mole. Okay, so we factor that in, then this entire thing becomes 88.4 joules. Let's put the units at the bottom, moles. Remember, we're going to change this mole into grams. So we do 1 mole times 58.08 grams over moles. So see, it changes into grams, okay? So if we simplify this entire thing, we'll get joules for every gram, but we need it for 10 grams because that's what the problem tells us. So we have to multiply the answer with 10.0 grams, okay? And so if we simplify all of this, and I forgot to add the Kelvin out here so that you still have a Kelvin unit at the bottom. So if we simplify all of that, we get 15.2 joules per Kelvin. And there you have it. Now it turns out, notice carefully how that entropy change is actually a positive number. That means that this process is spontaneous. I hope that made sense. Thank you for watching.